Hi guys, welcome to the lab experiment where we synthesize lidocaine, a local anesthetic. Lidocaine is synthesized in a two-step process. In the first step of the reaction, 2,6-dimethylaniline is treated with alpha chloroacetyl chloride in acetic acid in the presence of sodium acetate. This reaction is a selective substitution at the acyl carbon. In the second step of the reaction, the product of the first step, or 2,6-dimethylphenylchloroacetamide, is treated with diethylamine, and that diethylamine replaces the chlorine in an SN2 type reaction. This reaction is our first look at a multi-step synthesis protocol in the laboratory. What I want to bring your attention to is at the end of this lab, we will be doing a recrystallization, which is a great form of purification in the lab. Speaking of the lab, let's head there now. In the first step, the preparation of 2,6-dimethylphenylchloroacetamide. In a clean, dry 125 milliliter Erlenmeyer flask, we put 15 milliliters of glacial acetic acid. And to that flask, using a pipette, we will add 3 milliliters of 2,6-dimethylaniline. Using a syringe, we will add 4 milliliters of chloroacetyl chloride. Finally, we are going to add 25 milliliters of 50% aqueous sodium acetate to the flask. Now 60 milliliters of cold distilled water were added to the Erlenmeyer. As I was getting ready to add the water, I realized that the Erlenmeyer flask was actually warm to the touch. I used a spatula to break up some of the solids and get it ready for vacuum filtration. I turned on the vacuum system to create suction in my Buchner funnel. My Buchner funnel is equipped with a filter, and now I am pre-wetting it with the cold water, which is the solvent. So then we need to transfer all of the product under the Buchner funnel to filter off the cold water, which is the solvent, and to start drying our product. Again, rinse the Erlenmeyer a couple times with cold water to try to get the rest of our solid out of there, and we can continue to wash our product. Then we're going to use a glass stopper to press down on our product to try to push more of the water out. This is another method to dry your product. Once you've left it on the filtration system for a few minutes to dry, you can begin to start transferring your product into a weighing boat so that we can get it ready for the next step of the reaction. Make sure you remove the filter paper. At this point, we have synthesized 2,6-dimethylphenylchloroacetamide, and we are ready to take it on to the next step. Let's make some lidocaine. For this reaction, we will be doing a 45-minute reflux. To provide energy to our reaction, or heat, we will be using the heating mantle connected to the variac, which is then in turn plugged into the outlet. We will be using a reflux setup, which involves a water-jacketed cooled condenser. We will transfer our product that we made in the first step, the 2,6-dimethylphenylchloroacetamide, into a 100 milliliter round bottom flask. The solvent in this reaction is toluene, so we will use a graduated cylinder to transfer 25 milliliters of toluene into the round bottom flask. Finally, using a glass pipette, we will add 3.8 milliliters of diethylamine to the reaction vessel. You didn't see me put it in, but see the stir bar right there in the reaction? Once the contents of the round bottom are mixed, you can transfer your round bottom to the heating mantle. Using the lab jack, you can raise the heating mantle and round bottom to meet the bottom of our water-cooled condenser. Don't forget to secure that joint using a cat clamp. Now the next step is to turn the water on for the water-cooled condenser. The water is going to go in at the bottom and out at the top to keep the bottom of our condenser the coolest to be able to condense our liquid. Then we're going to turn the variac on and turn the dial to start the heating process. Once the contents of the flask begin to boil, we can start our timer for 45 minutes for this reflux. The reflux apparatus allows for facile heating to a solution, but without the loss of solvent that would result from an open vessel being heated. In the reflux setup, solvent vapors are trapped by the condenser, and the concentration of the reactants remains constant throughout the process, allowing for the constant supply of energy to a reaction over a long period of time. Using the close-up, identify where the reflux line exists in this reaction. Be sure to include a drawing or description in your notebook. Once we've refluxed for 45 minutes, we can turn the variac off and take the round bottom flask out of the heating mantle for faster cooling. Once the contents of the round bottom flask are cooled to room temperature, transfer them into a 125 milliliter separatory funnel, ensuring that the stopcock is in the closed position. And now for the extraction part of the lab. We will take our toluene layer and wash it 4 times with 5 milliliters of distilled water. Make sure that you shake and vent 3 times for each extraction. Once you have 2 distinct layers, you can determine which layer is which by using a pipette with water and seeing if it goes through or if it stays on top. In this case, it went through, confirming that our aqueous layer is in fact on the bottom. Now we will remove that bottom layer, that aqueous wash, for discard. And prior to discarding, I will verify one last time that that was the aqueous layer, and it is in fact aqueous. The toluene fraction will be washed 3 additional times with 5 mils of water, and those aqueous layers can all be discarded. Now we will wash that organic layer with 20 milliliters of 3 molar hydrochloric acid. This time we save the aqueous layer. And then we will wash that organic layer one more time with 20 milliliters of distilled water. Once collected, we will add this aqueous layer to the original HCl layer. The combined aqueous layers will be put into a 200 milliliter beaker and placed in ice. Now we are going to add 3 molar NaOH in 5 milliliter increments until the solution becomes strongly basic. I calculated that we would need about 20 milliliters of sodium hydroxide because we added 20 milliliters of HCl during our extraction. The addition of the sodium hydroxide is being completed on ice because we need to make sure we keep the temperature below 20 degrees C at all times. Okay, that's 20 milliliters now. Let's go ahead and test the pH using blue litmus paper. And it is strongly basic. Now that the solution is basic, we'll leave it on ice for a little while longer to have it further crystallize to form our nice solid product. Now we will use our Buchner funnel to vacuum filter our product. Don't forget to prime the filter with cold distilled water. And then check and make sure that the vacuum is intact and we have a seal. And then we will load our sample. It may involve rinsing out our beaker with a little bit of extra cold distilled water. It also may involve scraping with a spatula. Whatever you have to do to get the most product transferred, and then ultimately to get our product washed with that cold distilled water. Once you've washed it a couple times with cold distilled water, maintain the vacuum and let it sit on the filter for a little while to try to make it as dry as possible. Once dry, transfer your product into a pre-weighed 50 milliliter beaker. While transferring, try to get as much product as possible without scraping off any parts of the filter paper. There you have it. There's your product. Here's the mass. Let's see how much we made. Product on the day we made it and then the next week I waited again after it had more time to dry to compare. Set some of your sample aside so that we can do a melting point determination, an NMR spectra, and an IR spectra on your crude product. Last step, recrystallization. Recrystallization is a technique used to purify solid compounds. Solids tend to be more soluble in hot liquids than in cold liquids. So during recrystallization, an impure solid compound is dissolved in a hot liquid until the solution is saturated, and then the liquid is allowed to cool. The compound should then form relatively pure crystals. Ideally, any impurities that are present will remain in solution and will not be incorporated into the growing crystals. The crystals can be removed from the solution by filtration and subsequent washing with cold solvents. Please note that not all compound is recoverable. Some of it will remain in the solution despite it being cold. The solvent we will use to recrystallize lidocaine is hexanes. I heated the beaker very gently on a hot plate, being careful because hexane has such a low boiling point and is very volatile. The laboratory procedure said to add 1 milliliter of hexane per gram of product. However, after adding 3 milliliters of hexane, I realized I would need to add more. That was clearly a misprint. So what I did was I added hexane slowly until I got all of the product to dissolve. Once the solid was all dissolved, I removed the beaker from the hot plate and placed it in an ice bath to crystallize. Here is the crystallization process right before your very eyes. Once everything has crystallized, we will transfer to a Buchner funnel and remove all the residual solvents, washing it a few times with cold solvent as well. Transfer to a weighing boat to get the mass of our final product, 4% yield calculations. Make sure we take a melting point, an NMR spectrum, and an IR spectrum on this final sample as well, and compare these results with the crude product. And now, safety with Jane, but subbing in for Jane, Dr. C. Safety precautions that we have to worry about for this lab. All reactions must be done in the fume hood. Safety glasses and nitrile gloves must be worn at all times. Glacial acetic acid is highly corrosive to the skin and eyes, and because of this, must be handled with extreme care. 2,6-dimethylanilin is toxic and readily absorbed through the skin. You must wear gloves when handling this and any chemical during this experiment. Alpha chloroacetyl chloride is toxic, corrosive, and is a lacrimator. That means it makes you cry. Again, we must wear gloves. Diethylamine is toxic and is very foul smelling and will therefore be dispensed by your instructor. Please follow this procedure exactly. Stay safe. There you have it, the synthesis of lidocaine, where we learn 2 new techniques, reflux and recrystallization. Awesome!